Hello and welcome guys. Now in this tutorial we will be understanding the architecture of machine learning. Okay, so the architecture of machine learning pipeline include these of the various steps. Let's understand each of them step by step. Okay, so the first step in machine learning pipeline is to identify and and source the relevant data from the problem at hand. Okay, this could be involve collecting data from different sources such as databases, API or data stream, which is hosted in clients data, for example AWS, Azure, in any platform. Okay, then we have data ingestion. So in this step, what we do is so in this step we ingest the data into machine learning system. So this involves bringing the data into centralized locations such as data warehouse or data lake or data hub. Then we have data pre-processing. So once the data is ingested, it need to be pre-processed before it can be used for machine learning. Okay, so this step involves cleaning, filtering, transforming the data to ensure it is of high quality, relevant, and in the format that can be used for analysis. Then we have data exploration. So once the data is pre-processed, the next step is to explore the data to gain insight into its characteristics, pattern, and relationship. So this can involve using tools such as visualization, statistical analysis, and data mining to identify trend and anomalies in the dataset. Then we have feature engineering. Okay, so the next step is to engineer the feature that will be used for machine learning, and this involves selecting the relevant variables and transforming the data into format that can be used for modeling, and creating new feature that capture important aspect of data by combining two feature, three feature into one feature, like that. Okay, now for example, what I mean by combining multiple feature into one feature is, for example, name can be in different columns, like first name, middle name, and last name. So I mean, we know, right? I mean, these three feature can be combined to one column and can be used, right? So that is what feature engineering. So like concatenating important feature into you know one feature, like that, which can help us understand machine that okay, this is not different feature, this is just a name. Okay, so then we have model selection. So once the feature are engineered, the next step is to select the appropriate machine learning model that can best solve the problem at hand. This could involve selecting a supervised, unsupervised learning model, or choose a variety of model such as decision tree, neural networks, or support vector machines for given problem at hand. Okay, then we have model training. Okay, so once the model is selected, it need to be trained on data. This involves feeding the data into model and adjusting the model parameter to optimize its performance on the training data. Then we have model evaluation. So once the model is trained, it need to be evaluated on a separate set of validation data to test its performance. Like I told you in previous video, we will have two data set, one is train and another one is test. So test is used for this purpose. Okay, so this involve calculating metrics such as accuracy, precision, recall, and F1 score to assess the model performance. And these metrics that I have just told you, it not every time these all are used. Sometime they are used for purposes. So not every time accuracy will be best metric for evaluating the model. Not every time F1 score, not every time recall, like that, and it should be based on problem statement. Because sometime for us, it's not just about prediction. It's not just about how much accuracy we are getting. It's more about how much correct prediction we are getting, how much wrong prediction we are getting. Okay, so in that way we will see that later on as well. As then we have model deployment. So once the model is evaluated and deemed to be satisfactory, it can be deployed into production. This involves integrating the model into application or system where it can be used, for example website or application, mobile app, anywhere, and monitoring its performance over time. Lastly, we have model monitoring. Finally, the deployed model need to be monitored to ensure it is performing as expected and detect any anomalies or error that may arise. And this involves setting up monitoring tool and process to track the model performance and alert user if any issue has been detected. Okay, then overall the machine learning pipeline would involve set of interconnected steps that involve data sourcing, pre-processing, feature engineering, model selection, training, evaluation, deployment, and monitoring. Each of this step is critical to the success of machine learning project and require careful attention and expertise to execute effectively. Now all of this that we have learned is called CRISP-DM framework. So let me tell you about that as well. So so CRISP-DM we have learned in the start. You can go back and have a look. So the full form is cross industry standard process for data mining, that is CRISP-DM. So it is widely used framework for data mining and machine learning project. So it involves of 6 main stages that help guide the development of machine learning model. First is business understanding. So this stage involves understanding the problem that need to be solved and defining the project objective. Because see, what will happen is client will won't give you the problem statement at hand all the time. Okay, they will tell you the problem. You need to define the project objective, what it will be. Okay, it also involves identifying the data source and understanding the resources that are available. So and the next stage is data understanding. In this stage the data is collected and explored to better understand its quality, quantity, and characteristics. So this include data profiling, data visualization, and statistical analysis. Another step is data preparation. Once the data is understood, we have analyzed and we understood what are variable making sense, it need to be pre-processed to be ready for machine learning algorithm. So this stage include data cleaning, feature engineering, and data transformation. Then we have modeling, evaluation, and deployment. So these three steps basically involve selecting an appropriate machine learning algorithm, training it on pre-processed data, and evaluating its performance. And the performance metrics is done using various discussion with stakeholders and all, and then the model is fine tuned to improve the performance. And in the evaluation step, it need to be ensured that it meet the project demand, uh, project objective, and the model need to be tested on new data to ensure its generalizability. Okay, once this is done, the later is the deployment. So once the model is evaluated, it need to be deployed to production and integrated into a business process. This include monitoring the performance on the model and the making adjustment as needed. So this whole framework that we have just understood help guide development of machine learning model from start to finish. It provides a systematic approach to problem solving that help ensure the success of project. By following the framework, machine learning architect can ensure that they are building model that is effective, efficient, and meet the need of business. So this is all the architecture looks like. So hope you guys have learned something from here, and in the next tutorial we will be learning about algorithms. Okay, thank you.